Hello, in this video we are going to discuss about complex zero. So first, let's introduce imaginary number. So basically the imaginary number we use I, and the definition of imaginary number is I is equal to square root of -1. Commonly it's called imaginary number. Any real multiplied of an I can be also say an imaginary number. So if I is equal to square root of -1, then I have I squared is equals to -1. Okay, so for example, let's simplify square root of -9. So I can write it as -1 times -9, which is -9 is equal to 3. Square root of, not -9, square root of 9 is equal to 3. And the square root of -1 is equal to I, so that means I can write it at 3I. Okay, so for all of the complex number, they can return in the form, for all of the complex number, Z, they can return in the form of A plus B to the I, where A and B are real number. B is the imaginary part of the complex number, and I is equal to -1. So how do we do the addition, subtraction, multiplication, and the division for a complex number? So such as 3 minus 4i add 2 plus 5i. So these are two complex numbers. When we add these, we can remove the parentheses first and then merge the like terms. So the real terms merge with the real terms. So I have 5, and then imaginary part merge with the imaginary part. So I have a 5i. Subtraction is the same, but when it comes to multiplication, for multiplication is we follow the rule of distribution. We distribute 4 inside. I have 8 plus 20i. But what if I want to multiply two complex number? So what would you do? Well, we would just FOIL them. 2 times 1, 4i, and then 5i, and then plus minus 10i squared, and then simplify it. I have a 2, negative 4i plus 5i, I got I, and then negative 10i squared is equivalent to what? Negative 10 times -1, because I squared equals to -1. So if I continue to simplify, I have a 12 plus I. So when it comes to multiplication of a complex number, is going to follow FOIL. Okay, so when it comes to division, we will do this, like 2 plus 5i over 4 plus I. So when it comes to division, we need to simplify the division, so the numerator you can have I. So how can I get rid of I? What you will do is you multiply the conjugate. So the conjugate of a complex number would be this, 4 minus I. So that's the conjugate of the denominator. Sorry, that's the conjugate of denominator. Later I will talk about what is conjugate. So why would I do that? Because on the top I have a 2 plus 5i times 4 minus I, we just FOIL them out, but in the bottom I have 4 plus I and 4 minus I. So do you remember the differences of the square, which is a squared minus b squared is equals to a plus b times a minus b. Alright, so now this is basically is equivalent to 2 plus 5i. Now we don't need to worry about the top, because the top you can use the FOIL. On the bottom I have a 4 squared minus I squared. That made them to become a real number. So on the top again, you can FOIL them later by yourself. Now I want to focus on the bottom. So I have a 4 squared, which is 16, minus I squared, which is negative 1. So for the bottom, which is the denominator, I will have 17. That's how you rationalize the denominator. By multiply the conjugate. Okay, so what is conjugate? So the conjugate of a complex number a plus b a plus bi is a minus bi. So the notation usually is a plus bi. You have a straight line on the top. So your conjugate is a minus bi. So the conjugates help you to rationalize the denominator. So now let's get back to our polynomial. So in here I have a quadratic function. Quadratic function is one of the polynomial. How do I find the zeros? I want you to find the zeros of this function. Okay, I can use a quadratic formula, right? So x is equals to 2 plus or minus negative 2 squared minus 1, 5 over 2 times 1. So I will have 2 plus or minus negative 16 over 2. Okay, now negative 16. I can write it as what? Negative 1 times 16, which means when I remove the square root, I will have 4 times I over 2. Simplify it. X is equals to 1 plus or minus 2i over 2, because these two you can be eliminate. Okay. So this is what the application for the complex zero. So if I write it into the roots, how can I factor this function? Now we know the roots. If I told you that, hey, the root is, example, fx equals to x squared minus 3x plus 4, not plus 4, let's say plus 6 minus 5x. If in this one, I can factor it into x minus 6 times x plus 1. And then I have, if the whole function equals to x, the whole function equals to 0, I will have x either equals to 6 or x equals to negative 1. So here is similar, since now we have the zeros, which is the same as here. That's the 0 of the fs function. Let's use the g of x. So I can say that this is a g of x function. So 6 and negative 1 is the root of g of x function. And now I have fx is the root or the 0 of the fx function. So that means our fx function, I can factor into x minus, oh, the 2 already gone, sorry. So the answer should be, I write the answer wrong, should be 1 plus or minus 2i. Okay, again, if you take a look at here, x minus 6 equals to 0, then x equals to 6. So that means the root for fx function is going to be x minus 1 plus 2i, parentheses, times x minus 1 minus 2i, parentheses. Okay. So that's the application for the complex root. So now let's have an example. Example, fx, given the function fx x cubed minus 4x squared plus 9x minus 10. I want you to find the root and the complex zeros of the function. Well, let's see how many things we have learned so far. Well, if we use the rational roots theorem, we can have one of the possible real roots, right? So that I have all the possible roots is equals to p over q, where p is all the factors of the constant term, which means p is equals to positive or negative 1, positive or negative 2, positive or negative 5, positive and negative 10. And the q is the leading coefficient, all the factors of leading coefficient. Since this one only have a 1, so it will be 1. So that means all the possible root we have is positive and negative 1 divided by 1 is 1, and positive and negative 2, positive and negative 5, positive and negative 10. Okay, and now the next step is I use synthetic method to find which one is the real roots. Okay, I have 1, negative 4, plus 9, minus 10. Let's say if the root is 1, multiply here 1, negative 4 plus 1 is negative 3. And then we have negative 3, this is positive 6. 6, this is negative 4. Okay, so 1 is not the root because you have a reminder. Okay, so now we try again. Okay, so the next one would be, let's try 2. So I have a 1, 2 times 2, negative 4 plus 2, I have a negative 2. This is negative 4, I have positive 5. 2 times 5 is 10. So this is 0. Okay, so that means x equals to 2 is one of the real roots of the polynomial. Okay, now I can rewrite the polynomial as x minus 2, because the 2 is the root. So that means the factor has to be x minus 2. Times, this is x squared, x, and then constant term. So I have x squared minus 2x plus 5. Okay, so now we found one root. And now the other 0 is going to be, I let the whole thing equals to 0. The second factor is a polynomial. So that means I can use a quadratic function to solve that problem. Quadratic function is x equals to negative b plus or minus negative b squared plus or minus 4 times a times c over 2 times 1. So this is equals to negative 1 plus or minus 2i. So that means the root for this polynomial fx is going to be the zeros of fx is x equals to 2, s equals to negative 1 plus 2i, and then x equals to negative 1 minus 2i. Total of 3 roots, including a real root and 2 complex roots. Okay, that's it for today's class.